Hi guys, how are you all? Let me quickly do something guys before I forget. Someone. 1 second. 1 second. Give me a minute, okay? Eight 37. 21:37. Give me a minute, guys. 8:37. Models you can put. 8:37, 37. Okay, Jay is coming. Okay. How was the homework last week? Did you all understand? And let's see. What was the homework? I need to check. I did go over some of yours though. Any questions you all had, guys? G7, this is group 2, right? This is group 1 now. Yeah, this is group 1. Group two. Oh, okay. We did dilation. Okay, interesting to know. We did dilation. Have I finished? We did dilation last week, right, guys? Did we do dilation last week?
Yes.
Did you all understand that? Did you all understand that?
Yeah.
Some of you have not done it, right? I didn't want to pick out names, but did you all understand?
Yeah. Miss Priya,
Yeah, ma.
I did it, but I forgot to turn it in.
You did it. Who was that?
Me,
Oh,
Vedant.
last year. Oh, last year is saying she forgot. Who else?
Vedant.
Oh, Idant. Okay. So you did it, huh?
Yeah.
Okay.
I
So,
did most of it when I had time.
okay. Did you have any questions, Mitransh or Jay? Vikyat, if you submit the link, I cannot access. I have told you, right? You have to submit the PDF, Vikyat. You know me, right?
I'm sorry, I forgot this time.
You can never submit a link. That was the problem with your homework submitted. Lakshmita, did you understand and do, ma?
Yeah,
Nidhi, did you understand and do, or did you have any questions?
I don't have any questions.
Okay, so can I move on to other things?
I had questions, but I answered them myself before the class and I figured out what was wrong.
Okay, nice, Vikyat. But can I go ahead with translation? Guys, again, you're going to learn the same thing in geometry. So if you have a heads up now, it will be so useful in geometry. So that is the intent of doing all this. I'm going to go to, I'm going to go to other transformations. Can I go ahead? I'm going to get into other types of transformations. What is it? Rigid transformations. Let me see what is rigid transformations. Those are all interesting, guys. Okay. Well, last year, are they doing it in class? I'm just curious.
In class, we just finished Pythagorean theorem.
Oh, you just finished. Okay. Are they going to do transformations, ma?
I don't know.
Okay. I think they'll do for whatever they have time, based on that they might do. Okay. Sure, Lasya, you do. Will join after my mic because it has problems. Okay, Jay, please log off and log back in. Bharat, are you done with your star?
Yeah.
Okay, good. So we'll go ahead and do some rigid transformations. Okay. What is that? What is the difference between dilation? Dilation was a transformation to a pre-image where the size of the image changed, whether it became small or it became big. Big means enlargement. Small means reduction. Reduction, the scale factor was less than 1. Enlargement, the scale factor was greater than 1. Any questions still there? Any questions still there? Okay. 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 Now, what is that rigid transformations and what is not rigid transformations? First, let's find out what is that. They don't discuss that in here. Okay, they don't discuss that in here. Okay, then. Okay. Suppose you have a triangle here. Let's see what are, we already did dilation. Okay, I'm not going to discuss dilation here. Okay, I am going to have a triangle on one side of the coordinate plane. Okay, this is my coordinate plane. I have a triangle in here, here. Okay. Basically, what we are going to do is we discussed dilation. Okay. This was one transformation first we discussed. We are going to discuss translation. The next one we are going to do is rotation, reflection. That's it. Okay, these are the ones that we are going to study. In this, these three are called rigid transformations. Why? Because the size of the pre-image and the image are all going to be the same. It's going to be congruent. It's not going to change at all. But in dilation, it may become bigger or smaller. So that's not a rigid transformation. Okay. So these three are rigid transformation. But you have to know, right, if I keep on telling some sophisticated terms like translation, reflection, rotation, what will you guys know? It's very difficult, right? So what is this? Translation means slide. Slide the object. Move a little bit left, right, up, down. If you slide the object, it will go left or right, up, down. That's all. What is rotation? Who can turn? Who can say turn? Turn is rotation. Okay. What is reflection? What is a simple word for reflection? What do you do with it?
Reflecting over axis.
Correct. Flip. Flip on the x-axis or the y-axis.
Both.
Okay. Yeah, you can do both. Flipping on the x-axis or the y-axis. Okay. So, what is the interesting piece? For a dilation, you will hold at a point. Usually, last week when we learned dilation, the point of dilation was always the origin. Point of dilation means you're holding that end and then zooming it in. So that point of dilation was always the origin in whatever dilation you learned. Okay, if it is not the origin, it becomes complex. You'll learn that in geometry. We are not going to learn it now. Translation, you'll just move the object, right? It's going to move 3 units to the left, 2 units to the right, 4 units up, or 5 units down. Rotation, you will have a point of rotation. Usually it's the origin for us at your level. Okay. And then reflection, you'll have a line of reflection. Why? Because that line, let's say line of reflection is, let's say translation. How are you going to slide it? Say this is 1, comma 1. This is 4, comma 1. This is 6, comma 1. Suppose if I want to slide the objects, I will give my translation rule. I'll give you a translation rule like this. What would happen to the vertices of the triangle? You tell me what would happen to the vertices of the triangle. 6, comma 1 will become what? What it will become 6, comma 1? If my translation moving rule is x plus 3, comma y, what will happen to 6, comma 1?
It would be
We
9.
will- Yep, it'll be, the translation is the easiest. 9, comma 1. Then 1, comma 1 will become 1, comma 1 will become 4, comma 1. Correct. Y is not going to change, right? 4, comma 1. 4, comma 1 will become
7, comma 1.
Did I do it right? Yeah, 7, comma 1, right? Yeah, 1 minute. 1 second. Did I do it correct? 1 second, guys. 6, comma 1 will become, whatever you said was right, but 9, comma 1. 1, comma 1 would become 4, comma 1. 4, comma 1 would become 7, comma 1. So 9, comma 1 is somewhere here, right? And then 9, 9, comma 1, 6, comma 1. Correct. This is not 6, comma 1. This is 1, comma 6, guys. That's what confused me. Then that will be 4, comma 1, correct. So 1, comma 6 will be 4, comma 6. So it is moving to the right. Okay, 4, comma 6. So it will come here. 4, comma 6, 4, comma 6. Then 1, comma 1 will move to 4, comma 1. B will become B dash. 4, comma 1. A will become A dash. Then the last one is what? Let me put it 4, comma 1. 4, comma 1, which was here, will become 7, comma 1. This is 4, comma 1, correct. 4, comma 1 will become 7, comma 1. Something feels wrong. Correct only. 7, comma 1. So this is C dash. Now I'll join A dash, B dash. Do you get it, guys? Translation is not big, okay? It's just you have to see the rule and make the appropriate movement. Okay. Suppose if I do this, x minus 3, y plus 2. If this is the rule of transformation, right? What do you do, guys? Suppose if I give you a point 2, comma 5, how will it get translated? 2, comma 5 will get translated to what? Any thoughts, guys? Tell me, guys, what happens?
-1, comma 7.
Yep, -1, comma 7. So you now understood translation completely. Make sense? Very nice. Okay. Can I go ahead? Okay. Yeah. So now, let's say this is translation, right? Now, this okay. Orientation of what is this orientation of the figure? Okay, we learn all that. Center of rotation. Okay. Okay, let's see this one. Tell me, guys, this one. What is the translation of this figure? What is the translation performed in this figure? Translation is the easiest, okay? No problem. Okay, Kavin, I got your message. I'm glad you're here. So what is the translation performed in this picture?
Miss Priya, I wasn't here, so can you explain what translation is?
Jay, no, that is not accepted to me, for me at least.
My mic had problems, that's why.
I agree, but should you not be prepared before the class?
Yeah,
Is my expectation incorrect? No, right?
yeah, that's my bad.
The whole class will be pulled down if you do this. Okay, anyway, but it's my duty too. So translation is just movement to the left, right, up, down. But I'm glad you're asking. So I'm forced to tell you. Okay. So now A becomes A dash. So how many units to the left? You tell me. How many units it moved to the left? 2,
5?
3, 4, 5. You're faster than me. Yes. X minus 5. X coordinate was moved 5 units to the left. Y coordinate moved nothing. So this is the rule of translation. You got it?
Okay.
That's it? Easy?
Yeah, okay, I understand.
Okay. Now, so it's just moving left, right, up, down. Up, down means on the Y axis. X axis means left, right. Make sense?
Yeah.
Okay, now, how about this? What is the rule of translation? Yep. Bharat, that seems right. Mhm. Mhm. Adyan, is it X plus or Y? Last year correct. Varad correct. J correct. J, X comma J.
Huh?
Instead of 0, put X. That's all.
Oh, okay.
Kavin correct. Adyan, do you want to change? See, guys, okay, let me help you. A became A dash, right? 1, 2, 3, 4, 5, 6, 7. Wait, others are all putting different things. 1, 2, 3, 4, 5, 6, 7. Correct. So it moved on by 7. So y minus 7, but x remained as it is. Vikyat, did you get it? Idant, did you
I'm
get it?
working on my
Oh.
answer right now. But
Is
I
it-
got but I got for
So
A
you
it's
start
X minus
from
7Y
2020.
and then for C it's the same thing.
Nice. Idant, how about you, Idant?
Yeah, I got it.
Can I move on?
Yeah, it just takes a while to count.
What is it, ma?
It just takes a while to count the amount of
No,
spaces.
no problem, no problem. As long as you understand the concept, that is enough. Okay. Meaning when you come to geometry, right, there'll be kids who have not done this at all, but you would have done. So you'll really understand what is reflection, rotation, translation, all that stuff. So that is the intent of these classes after STAR. Make sense? Now, the thing is whether, okay, this is translation, right? Okay, you know what, let's first understand, I'm not going to deal with very complex ones, okay? But let's say the same triangle is in here. Okay, ABC is here. I said for reflection, there has to be a line of reflection. Line of reflection means what is my mirror? My mirror is the y-axis, okay? Now, in this case, what will happen to the vertices ABC when it is getting reflected? When it is getting reflected, can I say that this would be A dash, this would be B dash, this would be C dash? Are we all clear? Are we all clear?
Yeah,
Okay.
I'm clear.
Are you clear? Okay, this is reflection, right? What will happen if I rotate it around a point, let's say, okay, I'll come there. Suppose if I have this A, B, C, D, what will happen if I rotate this brick 90° to my left? 90°, not left, I can't say like that. 90°, let's say I rotate it counterclockwise. I rotate it 90° counterclockwise about the origin. Point of rotation is the origin. I rotate it 90° counterclockwise. What would happen? B will fall down. Then what happens? C comes here, D. Any questions? See, how did I draw that? A, B, this was the original line. I drew a 90° counterclockwise, right? Then I drew the line. Now again, for the next one, next side, BC, right? This BC is 90°. This BC rotated 90° counterclockwise. What happens? It will become something like this one here, BC. Now, how about CD? CD line, I have to rotate it 90° counterclockwise. Then that means what? It will be lying down. See here? Make sense? Idant, are you with me? Idant? Idant, are you with me?
Yeah,
Very tired?
yeah, sorry.
No problem. Okay. Here. So, if this is rotation, I already said translation means this is going to go down or up or something like this, right? Now, if it is A, B, C, D, what would happen? A is going to come down, B is going to come down, C is going to come down, D is going to come down. So you understand what is translation. You understood how to find out the rules in translation. Now you understood what is rotation. You understood what is reflection, correct? With all this, we are going to understand what will happen when I do a transformation. What is going to happen to several things, let's say. We need to discuss how the orientation of the figure changes, how the orientation of the vertices changes. This one, see, these are the fundamental knowledge that you need to have, okay? Orientation of vertices, orientation of the figure. Two things, orientation of the figure. How do these change in the three rigid transformations that we are making? Orientation of the figure, orientation of the vertices. How are they going to change? Let's first understand orientation of the vertices. How about this? I will draw the picture. Oh my God, I know I have a serious issue. Hold on. Give me a minute. I'm not able to paste. Ah, good. So look at this, guys. Now tell me what happened to the vertices. Meaning, vertices means in my original figure, okay, in my original figure, I go in a clockwise direction. I have A, B, C. What happened? What happened? What did I do here? I rotated, right? This is rotation, right? What is this? Who can tell me what is this transformation?
Reflection.
It's a
Reflection. Oh, yeah.
reflection on what?
X-axis.
X-axis. Now, we rotated here, okay? Somehow we are rotating, okay? It's like a rotation of what? Basically, it is a rotation of 270 degrees, huh? Yeah. So it's a rotation of 180 or 270 degrees? 180 degrees, I think. Yep. Now, tell me, what happened to the vertices? The original was ABC clockwise. Now, again, I'm going to go clockwise. This is the pre-image, this is the image, right, guys? Lakshmita, are you following, ma?
Yeah.
Vertices I go clockwise direction, A dash, B dash, C dash. Now, here this is the pre-image. What is the orientation? This is reflection I'm talking about. A, B, C. What happened to the image? After the transformation, what happens? Am I always going in the clockwise direction? Yes, I'm always going in the clockwise direction. Yep, I'm always going in the clockwise direction starting A. In the image, I got A dash, C dash, B dash. See the vertices. I always start from one vertex and go in a clockwise direction. To understand orientation of vertices, that's what I need to do. So, I showed you something. With this, what do you understand about the orientation of the vertices? Because of the transformation, orientation of the vertices stays the same or differs. Who can answer? I have written down the vertices of the image and the pre-image in each case.
Could you repeat the question again?
I have written down the orientation. Let's say rotated. This triangle was rotated here. In the original image, I started from A, went in a clockwise direction, wrote it as A, B, C, the vertices. In the transformed rotated image, I went from A clockwise direction, I wrote it out as A dash, B dash, C dash. This is for rotation. For reflection, in the pre-image, I went from A in the clockwise direction and wrote it out as A, B, C. In the reflected image, I went ahead from A dash, went in a clockwise direction, wrote it as A dash, C dash, B dash. Okay, we'll also do translation. Translation is very easy is what I thought, so I didn't do, but I can do it here. Let's say there is A, B, C. I just move it down. If I move it down, what happens? Comes like this, right? So here, this is the pre-image, right? I start from A clockwise direction, A, B, C. Here again, it became A dash, B dash, C dash. I went in the clockwise direction. This is the image. I'll write the orientation as A dash, B dash, C dash. Now, what do you think about the orientation of vertices in rotation, reflection, and translation? Say something about it. Whatever you saw and understood, you figure it out.
Like whenever you change it,
Yeah, how does it change? Does it change? Let's try here. One of you should tell me, I'm not going to tell. For rotation, did the vertices order change before and after the transformation? Did the order of the vertices change?
No,
No. Orientation of the vertices. Orientation of vertices was same. That means I can say orientation of vertices was preserved. Was preserved means it was exactly the same before and after the transformation. For reflection, earlier it was A, B, C. From A dash when I started, it became C dash, B dash. So what happened here? Orientation of the vertex, what happened? Vertices
it changed.
was not preserved. So reflection changes the orientation of the vertex, right? The last one, translation, what are we going to say? Orientation of vertices was preserved or changed? Guys, you have to tell me. Lakshmita, you
Preserved.
was preserved. Dilation as well, it will be preserved because dilation, you're just making it bigger or smaller. It's going to be exactly the same. So from here, what do we understand? We understand that the orientation of vertices is not preserved in case of only one transformation, which is reflection. In reflection, the orientation of the vertex is not preserved. Am I making sense?
Yeah.
Okay. Okay, how about this? Can I go ahead? Can I go ahead? How about this? Let's see. 1 second, guys. Sample of. Is it? 1 second. Rotation. Mm. Okay, how about this? Uh, 1 second, okay. I just need to know for you how to explain it. Okay. Can I delete this? Can I erase this off? Okay, let's go ahead with this one. So we understood about orientation of vertices. Orientation of vertices is not preserved only in reflection, correct? 1 second. I'm not able to paste. Why? I don't know. Hold on. Give me 1 minute. It's not pasting. That's not good. Okay. We should be able to paste now. Let's see, guys. No, unfortunately, no. Hold on. I really want you guys to see what I see so that you can understand as well nicely. How about this? Okay, now we are going to talk about this is too much. Okay, hold on 1 minute, guys. Sorry about. Okay, just wait. For some reason, good. You're all able to see my figure. Okay, now when you look at it, right, I'm just moving it to the left and just moving it down. What is this transformation? The first one, what is the transformation? What is the transformation I'm making?
Dilations.
What, ma?
Is it dilations?
Did I make a dilation? No, right? I'm just moving it to the left and then moving it down. What does it mean?
Translation?
Yeah, trans.
Oh, no.
Translation. Yeah, it is translation, guys. I'm just moving it to the left and moving it down.
Oh,
Does it-
I thought it was rotation for a second.
You thought. No, we didn't. Okay. Rotation comes here. See, here there is rotation.
Yeah,
Does it make sense?
yeah, I see.
Okay. Now, how about this? Orientation of the figure means what does, see, every word you need to give importance, okay? It's very, usually this is not explained in the class and also please understand the fundamental way the transformation works. So here orientation of the figure means we are discussing orientation of the figure. There are only two to remember, okay? One is orientation of vertex and orientation of the figure. What is orientation of the figure means? See, let's say I'll put a star on top. When I move or slide or translate the figure, right, the star just remains on top. It doesn't change its place. So what can I say about the orientation of figure? Does it change here or preserved?
It's preserved.
It's preserved. So it doesn't change. It's on top only. It's preserved. So orientation of the figure in case of translation is very much preserved. Okay. What do you think about dilation? What happens in dilation, orientation of the figure? Dilation is not in here. Last week we discussed. So in
It would be preserved, right?
Yep, orientation of figure is preserved because it doesn't change its place and all. Meaning, it doesn't change the way it is. Okay. How about dilation we did, translation we did. Now, let's go to rotation. What do you think happens to the orientation of the figure?
Not preserved.
Not preserved. Okay. I need to consider one reflection, right, guys? Okay, this one is a reflection clearly. Why? Because it was reflected on the y-axis first. It came here, and then it was reflected on the x-axis. So it came here. Do you think the orientation of figure is preserved in reflection?
No.
Yeah, orientation of
Right.
figure is not preserved. Yeah,
Oh,
correct.
yeah.
Not preserved. Because see, the star came down.
Yeah.
So this is the best way of explaining each transformation. So what do you understand? For the orientation of the figure, that is preserved only in translation and dilation. Rotation and reflection do not preserve the orientation of the figure. Okay. Reflection does not preserve anything. Orientation of the vertex also changes. Orientation of the figure also changes. Rotation does not preserve the orientation of the figure. Other than the translation dilation, all preserve orientation of the vertex as well as the figure. Any questions here? Any questions? Any questions?
No, I don't have them.
Okay, so basically this is as well, rotation is involved here. It's rotated. Okay, rotated. See, that's why it came down like this. When it is rotated, automatically the star that was on top came to the left. So in rotation, it's not preserved either. You got it? Can I move on?
Yes.
Yeah.
So orientation of the figure is a separate thing. Orientation of vertex is a separate thing. Okay, I hope you all understand. What is not which transformation does not preserve the orientation of the vertices?
Reflection.
Reflection, yeah. Which transformation does not preserve the orientation of the figure? Which two?
Reflection and rotation.
Yeah, reflection and rotation. Only thing is, if you rotate a figure by 360 degrees, right, then it preserves the orientation of the figure because it comes to the same place. Make sense?
Yeah.
Okay. Now, in all the four transformation, right, let me ask you this. In all the four transformation, what did we learn? Dilation, reflection, rotation. I'm just trying to discuss with you the properties. Okay, what happens in each transformation? What is that we learned? Translation. We learned about orientation of figure, orientation of vertex. We learned it already. Orientation of figure gets preserved. Orientation of figure gets preserved. In these two, it's not getting preserved. In reflection, nothing is preserved. In all these, it is preserved. Okay. Now, how about congruence? Is the pre-image and the image congruent in dilation? Is the pre-image and image congruent in dilation?
No.
No. Is the pre-image and the image congruent in congruence?
Wait, what?
I'm sorry. Is the pre-image and the image congruent in reflection?
Yes.
Yes. Is the pre-image and the image congruent in rotation?
Yes.
Yes. You don't change the size. That is why these three are called rigid transformations. Rigid means they don't change their sizes. You got it?
Yeah.
So this as well preserved. Do you see these are the properties that you need to be aware of? Any questions? So don't get bogged down with harder terms. Orientation of figure means, suppose if I have a star on top, does it change its place? Orientation of vertex means just write the order of the vertex going in either clockwise or anti-clockwise direction. You can go any direction. When you write out your vertices in the image and the pre-image, you should have the same. If you don't have, then it is not preserved. Can I move on? Can I move
Yeah.
on?
Yeah.
So now, okay. 10.A is done. Okay, how about this? Okay, this one I would like you to know. That preserve congruence. Okay, let's see. Okay, how about this? Let's rotate it and try. 90, okay, let's rotate it and try. I want you to try once, okay? Let's rotate 90-degree clockwise and see. Okay, let's rotate something 90-degree clockwise and see. Okay, let's say I have a figure here. A, B, C, D. I'm going to rotate 90-degree clockwise. What would happen if I rotated 90-degree clockwise? Who can tell me? This is, let's say this is X comma Y. You want to rotate 90-degree clockwise. How do you want to do? Rotate 90-degree clockwise. What will happen? Around the origin. If I want to rotate 90-degree clockwise, what would happen? First AD. What will I do with AD? 90-degree clockwise means this is the way, right? So this line, I will measure 90-degree from here, and this will be my line. So I will term this as A dash D dash. Always for the image, I'll put a dash. Okay. So that is my, this is where it came and sat. After the transformation, this is my A dash D dash. Now what happened to the next one?
You just flip it.
AB. Yeah, I'm rotating it. Rotate 90-degree clockwise. 90-degree clockwise means this, like this, you have to rotate 90 degrees. So this line becomes a short this line. Any questions there?
No.
Okay. The next one, what I need to do? This one earlier, right? It was at a 90-degree angle to this one, right? Here. However, it's sleeping line. But you have to rotate it 90-degree clockwise. So how would it come? 90-degree clockwise means this line would become this line, right? So it has to be 90-degree to this orange line. So it will come down. Am I making sense? Jay, are you getting it?
Yeah.
Okay, so this is going to be B dash, C dash, which will end the C dash, D dash, C dash, D dash, CD becomes that. Again, this line, when you want to rotate it 90-degree, clockwise, right? It's going to sleep. You see, this will become like this here. Make sense? Now, what happened to my C point? C point, which was X comma Y, became what? Who can guess? C point, which was X comma Y, became what? Who can guess this point?
Won't it be X comma Y? Because we don't know what X and Y is.
You don't know what X and Y is, but do you see this, just the rose color line is the rose color line. The blue color line is the initial blue color line. So what does that tell you? See, this was X distance. This level was Y. So now this became this. Do you see? So what happened?
It rotated.
Correct, it rotated, but how did X and Y transform?
They went from the x-axis to the y-axis.
Yeah, x-axis, how much ever was x, right? It became negative y. Do you see it? How much ever was positive y, what happened to that?
It became negative y.
Did it become negative x?
No.
We are still in the, here as well, x.
X.
It was positive x. Do you see, guys? It's slightly tricky. You know what? At the end of it, the 7th graders will start memorizing this. Oh, 90-degree clockwise rotation. XY. I'll start writing it down here. XY becomes minus y comma x. Did you get it, guys? Did you get it?
Yeah.
Now let's say, see, rotation 90-degree clockwise is the same as rotating anti-clockwise 270 degrees. Do you get it? 270-degree counterclockwise is the same as 90-degree clockwise. Am I making sense? If you rotate something 90-degree clockwise from here to here, that is the same as this is anti-clockwise 270 degrees. Am I making sense? 90-degree clockwise, you end up with this line, right, from the x-axis. It's the same as 270-degree rotation counterclockwise. Did I make sense, guys? Guys, am I making sense?
Yeah.
Okay. Now, if you rotate 180-degree clockwise, 180-degree clockwise means what? See, the x-axis rotate 180-degree clockwise. It's the same as this is anti-clockwise, right? 180-degree counterclockwise. It's the same as 180-degree clockwise. Make sense? But what would happen? Let's do it again. So, if I want to rotate 180 degrees, 180 degrees means this AD will become this AD, A dash, D dash. This is D dash, right? What would happen? 180 degree, I'm rotating it. I'm rotating it. Rotating, first making it up and then putting it down. What would happen? You're rotating. You're rotating 180-degree counterclockwise. So I should have done it better. You're rotating it 180-degree. First, you're turning it up. See, the blue color rectangle block is there, right? This rectangle block, right? I'm making it stand up. And then I'm pushing it down. When I push it down, that's 180 degrees, right? So it becomes like this. But what you need to understand.
Does it become both negative x and negative y?
Oh,
Or-
good one. Good one. You guys understood. Yes. What happens? X
It
comma
be-
y becomes
Negative x, negative y.
negative x, negative y. X comma y becomes negative x, negative y. Good job.
Wait, so does it work the same way as like a coordinate plane?
It's like the same as?
Coordinate plane?
Yeah,
Like,
this is a coordinate plane, Amma. From the first quadrant, it comes to the second quadrant. That's all. Got it?
Yeah.
Is it? Wait. I'm going up. No, I did not draw it correctly, right? I'm going to go up. Okay, I'm going to go up and then put it down. When I put it down, so what would happen? Rotate it here and then it will come here. So see what happens. It becomes like this, right? See, you make it stand up and then push it down. Push it down. Then in that case, yeah, minus x minus y. Correct. Make sense?
Yeah.
And then what? Next one. What is the one that we left out? Rotation of 90-degree clockwise. Rotation of 90-degree clockwise is done, right? What did we do first? Rotation of 90-degree clockwise of what did we consider first? We considered 90-degree clockwise. So what did we do? It was minus y comma x 90-degree clockwise. 90-degree clockwise we did. So it became clockwise, 90-degree, just 1 second, guys. I'm just checking. Hold on. I feel something feels so wrong here. Hold on. 90-degree clockwise is 90-degree clockwise is x became minus y, correct? But something feels so wrong here. It's the same thing as 270-degree. Okay, let's try this one. Okay, let's try this one. Something feels wrong though. Rotate 90-degree counterclockwise, 270-degree clockwise. What happens here? 90-degree counterclockwise means what will happen? 90-degree counterclockwise means you're not going to do this. You're going to go up. So what would happen if you're going to rotate this 90-degree? It would come up like this, right? Then this would become, this which was a standing line would become a sleeping line, right? And then this would complete it like this, right? Does it make sense, guys?
Yeah.
A, D dash, then this would be C dash, B dash. Correct, guys? So x comma y would become what?
Negative x, positive y.
X will become y, right?
Oh,
Because,
yeah.
So what would happen? X will become positive y, right?
Yeah.
Y will become negative x, right?
Yeah.
Am I making sense?
Yeah.
Lakshmita, Lasya, did you guys get it? Lakshmita, Lasya, did you get it?
Yeah, I got it.
Okay, you know what? I will take this out and I'll share a cheat sheet with you. Can I erase this off?
Yeah.
Okay, you know what I'm going to do? Since you understood how this comes, right? Let me see, guys. Transformation cheat sheet. Yeah. So this is what I used to share with others, but there was something wrong with this though. 90-degree. So I'll share a sheet like this with you guys. You can use this, which is still okay. Once you understand, it's okay to memorize this. Hold on, I'll share with you something like this. Do you all see my screen? Do you all
Yeah.
see my screen? Okay. So for translation, what did we study? Translation, we studied x comma y becomes x plus or minus h, y plus or minus k. Do you all get it?
Oh, yeah.
For dilation, x comma y became the scale factor times x, scale factor times y, correct?
Yep.
For rotation, x comma y, this is what is the rule, this is how they derived the rule. Does it make sense?
Yep.
Okay. This one is x comma negative y, y comma, somewhere one of this is incorrect. I will correct it and give the cheat sheet to you. Okay. So, but do
Okay.
you understand how this rule came up now?
Yeah.
A block is being rotated. Literally construct the block. This block is rotated 90-degree counterclockwise or 90-degree clockwise or 180-degree counterclockwise. When you rotate it, let's say this point is x comma y. How did it change in the image? After the transformation, what happens? Suppose if 2 comma 3, let's say, okay, for rotation itself, we'll do one. Now, this one is, I don't want this color. Okay, now, let's say this is 4 comma 0, x4 comma 0, right? Now, this is 4 comma 1. Now, 90-degree clockwise rotation. What will happen to 4 comma 1? 90-degree anti-clock. Please, counterclockwise. Counterclockwise means it goes 90-degree like this. So, what would happen to that point? Who can tell me? 90-degree counterclockwise. 90-degree counterclockwise means like this it goes. What happened to the point 4, comma 1? What will happen? Or 4, comma 0. Let's say 4, comma 0. What happens to the point 4, comma 0? If it's rotated 90-degree counterclockwise. Tell me, guys.
Does it become negative 4, 0?
Does it become negative 4, 0? See here. 4, comma 0. What would happen? X becomes X here. You see? Y point becomes minus Y. So 0, comma 4. Do you guys get it? That will be your B dash, right? Am I making sense?
Yeah.
This point will shift up, right? Does it make sense, guys?
Yeah.
Okay, now 4, comma 1 will become what? Let's say we have a 4, comma 1 point. What will happen to that point? See, Y shifts to the X with a minus. Minus 1, comma 4. Am I making sense?
Yes.
So this is how you use the rule for transformation to find out the transformed coordinate point. Let me give you one example. I'll give you a cheat sheet and an example, okay? There is something wrong in this actually in the rotation. Hold on. So let me go ahead and give you a problem to do for rotation. Lakshmita, last year, did you get confused or did you understand?
I understand.
Okay. Rule. 1 second. Okay, rotation rules. Okay. Clockwise is 1 second, guys. 90-degree clockwise is Y minus X. Okay, let's do it here. This is the rule. Okay, all clockwise rules. So let's go ahead and have this in place and we'll see for each. Again, okay, again I'm stuck. 1 second, guys. I need to close this out. Okay. Okay. You should be able to paste. Okay. Do you see the rules there? Let me give you one problem on rotation. Okay. Let's see. You know dilation, but you want rotations, right? 1 second, rotation. Reflection, we can do it next week, okay? How about this? I have a figure, okay? This is 90-degree clockwise rotation about the origin. I have a figure, see? I have a figure. Now, when you look at it, right, what sort of a transformation is this? Who can tell me what sort of a transformation is this? See, this
Rotation.
rotation of what?
Counterclockwise.
Yep, 90-degree.
Counterclockwise.
Yep, counterclockwise about the origin. Counterclockwise. Okay. Now, A point was what? 1, comma 1. Okay. B point was 1, 2, 3, 4, 5, 6, comma 1. With this, we'll complete, guys. C point was 4, comma 1. 1, comma 6, right, guys? Please, if I make a mistake, you have to let me know, right? 1, comma 6. Now, can you tell me what are A dash, B dash, C dash? Can you tell me what are A dash, B dash, C dash? Please, 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 please don't abuse this, okay? Meaning, what I'm saying is, I'm going to give you only this, guys, okay? So, I'm not going to give you this picture. Let me give you only the original pre-image. Okay, I want you to find out what is A dash, B dash, C dash. I want you to find out what is A dash, B dash, C dash. Can we try that? I want you to find out what is A dash, B dash, C dash. Let me see. For this one, how will we find out A dash, B dash, C dash? Please help me. I'll help you. It's like that. Okay. I'm not going to be the person who is completely doing it on the board. I have written down the points, right? This is X comma Y. Apply to the rule. We are doing a 90-degree counterclockwise. That means it's the same as 270-degree clockwise. So X comma Y will change to minus Y comma X. So what will happen to 1 comma 1 point? Come on guys, quick. I'm going to wait.
Does it become negative 1, 1?
Yeah, it becomes negative 1, 1. Now B, 1 comma 6. 270-degree clockwise is the same as 90-degree counterclockwise. So 1 comma 6 will become what?
Negative.
1.
Negative 6. Negative
Correct.
6, 1.
Negative 6 comma 1. 1 will remain the same, but it will become the Y. Good. 4 comma 1 will become 4 comma 1 will become
Negative 4, 1.
negative
4?
X.
Isn't it -1?
Negative 1, yes. See, the Y will shift to a negative Y. Do you get it? Minus 1 comma, the X will shift as it is. Make sense?
Yeah.
So now what will be the rotated points? When you look at this triangle that was in here was rotated 90 degree. So minus 1 comma 1, minus 1 comma 4, see? Minus 1 comma 4 and then minus 6 comma 1, see? It was rotated. You get it? It was rotated 90 degrees. Make sense?
Yep.
This became this. Make sense?
Yeah.
Okay, so what are the coordinate points? So basically this is A, B, C, let's say. Now that became A dash, C dash, B dash. Wait. A, B, C, it was rotated 90-degree counterclockwise. So it became, we are rotating 90-degree counterclockwise, right? Yeah. So the bigger one, yeah. A dash, C dash, B dash. Yep. C dash is minus 1 comma 4. C dash. Okay. So the top became here, correct? This became B dash, correct. And then minus 1 comma 1, correct. Minus 6 comma 1, minus 1 comma 4. Okay, correct. So what did we use? Minus Y comma X. Everything is correct. Okay. So let's say for us to be very clear, right? Let's say this is a smaller triangle like this. Okay, the base is small. Then what happens when you rotate it? What happens when you rotate it? This is going to become larger. This base is going to be smaller, like this. Any questions? Any questions, guys? Any questions?
No.
No.
Okay. Can I stop here? Can I stop here?
Yeah.
You know
Yeah.
what? But this week I'm not going to give you much of a homework. Next week we'll combine reflections and then do a lot of homework. Okay?
Okay.
Okay, guys. I'll give you the base homework something. Okay? Bye.
Bye.
Bye, Miss Priya.
Bye, guys. Bye. Just for
Bye, Miss Priya.
rotations, I'll give you. Bye. Lakshmita, was it difficult?
That was fun.
Okay.